What's up, calculus students? Mr. Messner coming at you with the 0.2 homework where we are kind of going backwards with what we did day one. We talked about in class, and it's important to remember that it always goes, I'll write it here. The trig function of an angle equals a ratio. Day one, I gave you the trig function and I gave you the angle. You then provided the ratio. Day two, I give you the trig function, I give you the ratio, you give me the angle. So we're going to be having answers that have like pies in them because radians all are kind of like involved with distance around the unit circle, circle's radius 2 pi r, or circle's circumference 2 pi r, r being 1. So we're looking for answers with pies except for the angle of 0. This is great. How do we do this? I like to say start with your triangles. You got 3 different triangles, really 2, a tall 30, 60, 90, a short 30, 60, 90, and your 45, 45, 90. And just remember the tall 30, 60, 90 occurs with a 60-degree like base reference angle at the pi over 3s. We know that the short side is a half and the long side is root 3 over 2. Short 30, 60, 90 triangle is at the pi over 6s, and the 45, 45, 90 triangle is at the pi over 4s. Okay, so we start with that in our brain or written down on the paper. And then we say, okay, I want to know the angles when cosine equals a half. Using SOHCAHTOA, the cosine is the adjacent over the hypotenuse. The adjacent is always the horizontal length for our trig functions in our unit circle. So I then come to one of my 3 triangles and I say when is the horizontal equal to a half? Here we have the horizontal equal to a half. So we are going to have pi over 3 angles. But one extra thing we have to pay attention to is that there's an infinite amount of angles where the ratio is going to create this 1/2. So we have to make sure we understand which trig functions are positive in which quadrants. Cosine is positive in the first and the fourth quadrants. So my answers are going to be the pi over 3 in the first quadrant and the pi over 3 in the fourth quadrant. I know my answer has to be a pi over 3. I know this answer has to be a pi over 3. The key is like, what are the numbers before the pi over 3? How do we remember how to do this? Well, we know we start 0, we go positive. Here's 1 pi over 3. So that's good. 1 pi over 3. It's probably best if you go all the way around your circle to 2 pi, which is 6 pi over 3s, and then subtract a pi over 3. Very similar to what we were doing last class. Know that that's the location of 5 pi over 3. So my answers for x, if I was asking you to find all of the solutions between 0 and 2 pi, my angles are pi over 3 and 5 pi over 3. I'm going to move. This is way too loud. All right, now I'm over here now. Okay, so triangle, correct radian, correct quadrant. Now we got the sine, which deals with the opposites being a half. Don't worry about the negative yet. Instead, you're just like, okay, here is the opposite being a half. It's at the pi over 6. I know I have 4 possible pi over 6s where the reference angle is 30 degrees, but I want to know when sine is negative. Again, if we do all students take calculus, We know that sine is negative in the third and the fourth quadrants. Why? Because we're going down. So I'm going to go here and I'm going to go here. These pi over sixes. This pi over 6, this pi over 6. What are those pi over 6s? Well, I can start at pi. Remember, going counterclockwise is adding. Start at pi, add a pi over 6. I could do 6 pi over 6 plus a pi over 6 to give me 7 pi over 6. Get all the way around to 12 pi over 6, or 2 pi. Subtract a pi over 6, 12 pi over 6 minus pi over 6 is 11 pi over 6. So my two answers are 7 pi over 6 and 11 pi over 6 between 0 and 2 pi. We will talk about all solutions eventually. Let me just give you an example of like all solutions for the next one. Okay, cosine, negative root 3 over 2. Cosine in SOHCAHTOA is the adjacent, which is the horizontal side. Which triangle has the adjacent side root 3 over 2? Well, that's when the longer side of a 30, 60, 90 triangle is the adjacent side. That occurs at the short 30, 60, 90 triangle, just like this one. So here is my adjacent side being root 3 over 2. Cool, that occurs at the pi over 6s again. But I want the pi over 6s when cosine is negative. Cosine is negative in the second and the third quadrant. It's positive in the first and the fourth. So I want the pi over 6 here, and I want the pi over 6 here. This is 6 pi over 6. Subtract a pi over 6, add a pi over 6. If you are asked to provide the angles between 0 and 2 pi, this is your answer. If you are asked for all possible solutions, you would say these angles and all coterminal angles, adding 2 pi n, where n is an integer, means like if you go all the way around to 17 pi over 6, the cosine of 17 pi over 6 is the same as the cosine of 5 pi over 6, which is negative root 3 over 2. But I did not ask for that, so we're good at that. All right, now we have our friend Mr. 45, 45, 90 triangle. Again, if you just have those three listed, you can always reference those. Cosine is the adjacent. Doesn't really matter. You know it's 45. And now we just want to remember these are the pi over 4s. I want the pi over 4s when cosine's negative here and here. This is 3 pi over 4. This is 5 pi over 4. I add and subtract a pi over 4 from 4 pi over 4, which is just pi. Now, you guys do not have to show this work. You can just write down the answers. If you have the triangles in your head, you're good. I'm providing all of the steps and all of the work to help you if you need that help, okay? So if you're able to just like blow right through this, no, that's great. Just get the right answers. You don't have to do what I'm doing. This might help you. All right, we're back in the land where the opposite side is the longer side of a 30, 60, 90. So I want the tall 30, 60, 90 triangle where the opposite side is root 3 over 2. That occurs at the pi over 3s. I want the pi over 3s where sine is positive. Sine is positive in the first and the second quadrant. Therefore, I want this pi over 3 here, and I want this pi over 3 here. 1 pi over 3 added from 0. You can either add another pi over 3 to get to 2, or you can go from 3 pi over 3 and subtract going clockwise to get your other one. It's loud over there. Tangents are tricky because it's not obvious and it's not something that's memorized, but you got three options. Which is the option that's going to work? Well, maybe we'll write down the three options again. Tall 30, 60, 90. Well, that was bad. Tall 30, 60, 90. Short 30, 60, 90. And we should know that it's not going to be the 45, 45, 90. We know that it's not going to be the 45, 45, 90 because opposite over adjacent would be 1 because it's an isosceles triangle. So we understand that tangent is the OA in the SOHCAHTOA. So the O over the odd needs to equal this root 3 over 3. Well, remember, we're referencing this angle here, this base angle. So one of these 30, 60, 90 triangles will give you this root 3 over 3 ratio. Which one is it? I don't know. Do the math. Figure it out. This one, the O, A, ends up not working. You'd get root 3. That's not root 3 over 3. So this one, and after you do tangents enough, you know, like you have root 3 over 2 in the top and a half in the bottom, that the 2's will cancel. So maybe you could just keep that in your brain. That way you don't have to do all the work all the time. This one, the O, A, simplifies to be 1 over root 3 after the 2's cancel, but the root 3 stays in the denominator. And this can be rationalized to be root 3 over 3. So after doing that work, we know that this is our winner. That lost. We know that lost. This is the winner. It's at the pi over 6's. Which pi over 6's do we want? The pi over 6's when tangent is negative. Tangent is negative in the second and the fourth quadrants. That is 5 pi over 6 and 11 pi over 6. How do I know that? 6 pi over 6 minus 1 pi over 6. 12 pi over 6 minus 11 pi over 6. 12 pi over 6 minus 1 pi over 6. Cool. Plus 2 pi n if they say all solutions. All right, we should be ready for this one. After what we just did, we know the tall 30, 60, 90 is going to be opposite over adjacent. Opposite over adjacent will give us root 3. This is the tall pi over 3 angle, 60-degree reference angle. So we want when tangent is positive. Tangent is positive in the first and the fourth. So I want this pi over 3 and I want this pi over 3. We know the answers have to be pi over 3's, have to be pi over 3's. They have to create this tall 30, 60, 90. This is 3 pi over 3 plus a pi over 3 to give us 4 pi over 3. This is 0 pi over 3's plus a pi over 3. So I get pi over 3 and 4 pi over 3. When you deal with reciprocal functions, unless it's cotangent, probably the best thing to do is just to flip everything. If cosecant equals 2, well, then sine has to equal a half. Don't really try to answer this question, though. You can do it. It's fine. Answer this question, sine equaling a half. I don't think we did this one already. Short 30, 60, 90 triangle. The opposite side is going to be a half. This occurs at the pi over 6's. I want the pi over 6's in the first and the second quadrant. 0 plus 1 pi over 6, 6 pi over 6 minus 1 pi over 6, 5 pi over 6. Our goal, guys, to probably try to get this into our brains. So we could just do it. Like I could do sine equaling a half. It's like, okay, half, not root 3 over 2, short, pi over 6, pi over 6 here, pi over 6 there. Boom, you get your answer pi over 6, 5 pi over 6 without all the work, okay? You don't have to show your work in this class. There will be times when we'll really, really have to, or else we won't be able to get the right answer. But this is a situation where you can get the right answer without showing the work. Now, this one's interesting. If I flip this, I get this. What the heck is 3 over 2 root 3? Well, if you rationalize it, maybe you can see it a little better. I get 3 root 3 over 2 times root 3 times root 3 is 3. Oh, look at that. The 3's cancel, and I get root 3 over 2. So actually, secant equaling 2 root 3 over 3 is equivalent to cosine equaling root 3 over 2. Cosine root 3 over 2, longer side in a 30, 60, 90 to be the adjacent, the longer side being in the adjacent short 30, 60, 90 triangle, where this is root 3 over 2, which occurs at the pi over 6's. Pi over 6's are the winners. We need to find the correct pi over 6's, where cosine is positive. Cosine is positive in the first and the fourth quadrants. So I want this pi over 6, and I want this pi over 6. It's really easy to actually say 1 pi over 6 and negative pi over 6. Think about this. 0, add a pi over 6, subtract a pi over 6. However, you are told to keep your answers between 0 and 2 pi, which is why we would prefer you do 1 pi over 6 and then go all the way around to 12 pi over 6, which is 2 pi, and subtract a pi over 6 to get 11 pi over 6. Not sure what to do? We'll isolate the trig function, subtract 2 from both sides. Okay, we have an extreme situation. What angles does sine equal 1? Okay, that's when my vertical or my opposite is 1. In the unit circle, for the opposite side length to be 1, we need to be going straight up. Straight up is our 90-degree angle, pi over 2. Just make sure you go in the correct order. Subtract 8, then divide. If I subtract 8 and then divide, I get that. I'm going to show you how you can do it. Like, okay, adjacent a half, tall 30, 60, 90 triangle. Okay, pi over 3's. Pi over 3, when cosine is negative, this is in your brain, is in the second and the third quadrant. 3 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. There you go. I wonder if we have more extremes. Kind of want to do more extremes. We'll practice them next class. If I add 9 root 3 to both sides, I have 18 cos x equals positive 9 root 3. I then divide by 18. 9 divided by 18 simplifies to be 1 over 2. Boom. Cosine is the adjacent. We need the pi over 6's, where the adjacent is root 3 over 2. We need the pi over 6, or cosine's positive. So that's this pi over 6 and that pi over 6. So again, pi over 6, negative pi over 6, or pi over 6 and 11 pi over 6. Oh. Mosquitoes. Ah! What happens if we have cosine equaling sine? Well, I taught you this in class. Divide by cosine. what happens? 1 equals tangent. Oh, tangent equaling 1. Again, your three situations. Which one will tangent equal 1, where the opposite over the adjacent will equal 1? The oa in SOHCAHTOA equaling 1 occurs at the pi over 4s. We want the pi over 4s, where tangent is positive 1. A big mistake students make with this problem is they're like, when are sine and cosine equal to each other and both positive? And they say, oh, just pi over 4. But here's a big mistake. It's not when they're both positive. It's when they both equal each other. You can have 5 pi over 4. And sine and cosine are both negative root 2 over 2 at 5 pi over 4. So make sure you get all possible solutions. Mistakes made there. This question is not when is sine negative or the opposite of cosine. You can see that if you divide by cosine, the question is really, when does tangent equal negative 1? Well, positive 1, then I'm going to move the negative sign over. This question is actually, when does tangent equal negative 1? So again, it's going to be the pi over 4s where tangent equals 1, but it's going to be both this pi over 4 and that pi over 4. Many students will answer just this pi over 4, 7 pi over 4, but it's not that one. It's when are they opposites of each other. At 3 pi over 4, sine is positive, cosine is negative, the equation fits. So make sure you have both 3 pi over 4 and 7 pi over 4. This is 4 pi over 4 minus a pi over 4. This is 8 pi over 4 minus a pi over 4. I feel like we did this already. This is going to be the short 30, 60, 90 triangle. This is 1/2. This is root 3 over 2. If I do the math, 1/2 divided by root 3 over 2, I'd end up with 1 over root 3, which is root 3 over 3. So the pi over 6s are the winners. If you're not sure of that, just start with your two different triangles and do the math and figure it out. The pi over 6 when tangent is negative is this pi over 6 here. Let's switch back to this pi over 6 here, that pi over 6 here. I feel like we did this question, but whatever. I'm on a roll. Let me cook. All right, we got some zeros here. We did this one. We want the tall, the pi over 3. We want the pi over 3 here and the pi over 3 here. 1 pi over 3, 4 pi. This is sine equaling 1/2. I want the pi over 6 here and the pi over 6 here where sine is positive. I feel like this is a poor homework that I put together. I want you to do, we'll have to do more extremes in class for practice. We'll see them actually when we do the factoring ones. This is the same as cosine equaling root 3 over 2. Cosine equals root 3 over 2. Figure it out at pi over 6 and 11 pi over 6. I'm thinking about the triangle. I'm thinking about the adjacent side. I'm thinking about cosine being positive. Triangle is the pi over 6s. Cosine's positive in the first and the fourth quadrant. Yeah, look at that. Things are not even on the right spot where I printed it out. We get to these questions, which are actually good questions, which breaks out our friends, the zeros. Try to get out of the sun here. There we go. How do we attack these problems? What's our first step? Well, if I gave you the question 2x squared plus x equals 0, how would you solve this equation? Whenever we have x squareds and x's, we have a quadratic equation. We always want to look to factor to help us solve. You can factor out the common factor of an x. And then you have two different equations. We have x equaling 0. We have 2x plus 1 equaling 0, or x equals negative a half. Now, I don't want to confuse you by using x's. Why don't I just like switch this to like a? That way you're not confused. Yeah, let's do a for the reason of removing confusion. So yeah, we have a product equal to 0. If either piece of our product equals 0, the entire thing's going to equal 0. So this could equal 0 or that could equal 0. And we get answers. So we get a equals 0 or a equals negative a half. Now, if I go and think about what I just did, it should make sense that you could factor out a cosine term from both of these terms. Now, when you factor out or divide out the cosine x from cosine squared x, you're left with 1 cosine x from this first term. When you divide out a cos x from this cos x divided by cos x is 1. Here is our product set equal to 0. We like products equal to 0 because either this piece could equal 0 or this piece could equal 0. Let me work with this piece first. It's easy to isolate the cosine. And then we got the pi over 3s in the second and the third quadrant. Cosine adjacent SOHCAHTOA, adjacent a half is going to be at pi over 3s. The pi over 3 in the second and the third quadrant are part of our solutions. And now let's look at this one. When does cosine equal 0? A lot of people make an error. We did this in class. People think, oh, 1. The cosine of 0 is 1. Well, that's not the question. The question is, what is the angle when cosine's ratio is 0? Or what is the angle when the adjacent side length is 0? The angles when the adjacent side lengths are at 0 are actually your verticals, pi over 2 and 3 pi over 2. You don't go to the left or the right at all. You just go up and down. So the cosine value at pi over 2 and 3 pi over 2 is 0. That gives me my 4 solutions here. Try to list them from least to greatest just to get used to it. We can see pi over 2, then 2 pi over 3, then 4 pi over 3, then 3 pi over 2. Cool. Same thing. You guys try yourself. Factor. Factor. Product equals 0. 2 pieces of product equaling 0 will make the entire product equal to 0. 0 times anything is 0. Now we have sine equaling 0 or sine equaling 1. We did this earlier, sine equaling 1, this extreme. That's on the straight up and down. So that's going to be at pi over 2. Not at 3 pi over 2. That doesn't work. When does sine equal 0? When does the opposite equal 0? The opposite equals 0 when we don't go up or down at all. We don't go up or down at all at 0. We don't go up and down at all at pi. We don't go up and down at all at 2 pi. Do we need all three? Isn't 0 and 2 pi really coterminal? Aren't they the same location? They are. Are they different angles? Yes, they're for certain they are. Pulling a 360 is a lot different than pulling a 0. I told you guys to include all solutions from 0 and 2 pi, including 0 and 2 pi, which means if you have 0 as an answer, you have to have 2 pi as an answer. It's not like a big deal. Don't stress out about it. Maybe list them off in order, but like I would not mark you off on a quiz if you did not include 0 and 2 pi. All right, very similar. Let's factor out a tangent, and I got root 3 tangent x minus 1 equals 0. First one is when tangent x equals 0. Tangent's the OA, the opposite over the adjacent, which is the vertical over the horizontal. To get a ratio that's 0, I need a 0 in the numerator, and the denominator can be anything. We don't want to divide by 0, that's undefined. We want 0 in the numerator. So tangent equaling 0 is actually when does sine equals 0. So just like here, 0 pi, 2 pi are going to be 3 of my answers when sine is 0, when the opposite's 0. Now this one's going to be fun right here. Root 3 tan x minus 1 equals 0. Add 1, divide by root 3. Don't make a mistake on the algebra, guys. Don't say tan x equals negative 1 over root 3. Don't say tan x equals root 3 over 3. Like, do the math, add 1, divide by root 3. I'm not going to rationalize this. I'm going to leave it like that. I'm thinking opposite over adjacent needs to be 1 over root 3. I have my options, but I know which one I want to go with. I want to go with the short 30, 60, 90 because 1/2 divided by root 3 over 2 will give me that 1 over root 3. That's the pi over 6's. The pi over 6's are the winners. I want the pi over 6 when tangent is positive. So that's this pi over 6 and that's pi over 6. That's 0, 1 pi over 6. This is 6 pi over 6. Add 1, 7 pi over 6. So we got 0 pi over 6 pi, 7 pi over 6, 2 pi. For these last two, I don't want to stress you guys out about it. It's not a big deal. So it won't be on your test and it won't be on your quiz. Let's just get rid of this interval and let's just talk about all solutions. Find all solutions. Just in general. Just like ignore this. I know many of you are probably coming to this video just for these two questions, but like on the original homework, I had a whole another page of this stuff. And honestly, it's not that important and I don't want you to stress out about it. So we will just like finish with these 4 and we will not pay attention to the interval and you're gonna be like, okay, I get this. But I do want you to understand what all of the possible solutions could be. So we got this 5x over 6 going on here. What does that mean? Well, let's just start with like cosine of what angles. Sometimes we can replace something we don't want to deal with something else and say like, yo, let's just worry about that later. Okay, substitution is very important in mathematics. So step 1, replace, deal with it later. Let's figure out what these angles y can be. Again, this is going to be our angles y. You could have also said your angles equal 5x over 6 and you could have just got right with 5x over 6 equals your angles. Up to you. Make sure you know how to get this answer of the 2 pi over 3 and the 4 pi over 3. And don't forget that if we're looking for all possible solutions, we're going to look at everything coterminal. So plus 2 pi n's is going to be good. Now, these are our angles. However, these are not our solutions for x. We have to take x, multiply it by 5, and divide by 6 to get our solutions. So watch. I'm going to take every single one of these fractions and get rid of this 5, 6 so that I can have solutions for x. We have to take our angles, manipulate them to get our solutions for x. Let's multiply everything by 6/5. What do we get? Well, like 12 over 15. Actually, 6 can be divided by 3, and that becomes 2. Gives me 2 times 2 pi over 5. If you don't understand that that's 4 pi over 5, you could do your math yourself. 12 over 15 simplifies to be 4 over 5. 6 divided by 3 is 2 over 1. So this is going to be 8 pi's over 5. And then to get more solutions for x, we could add multiples of 12 pi over 5 to them. So that means like adding 12 gives me 16 pi over 5. Like that's a possible solution. That's what it means to like add one of these multiples. Not a big deal. I think the biggest deal is that being able to get these two answers. I actually have never seen on an AP test, they force you to look beyond 0 and 2 pi. They usually stick to 0 and 2 pi. Next, same deal. What are my angles where sine equals a half? Sine equals a half at pi over 6 and 5 pi over 6. I'm not going to show the work here. And all coterminal angles to that. But what are my solutions for x? Well, my angles for y are pi x over 4. To solve for x, I will need to get rid of the 4 and the pi. We can divide by pi over 4, multiply by the reciprocal. So I'm going to take all of our stuff and multiply by 4 over pi, multiply by 4 over pi, multiply by 4 over pi, and get my answers. The pi's cancel. 4 over 6 is 2/3. The pi's cancel. 4 over 6 is 2/3, so 2/3 times 5 is 10/3. Plus multiples of 8. That's it. So, like, do you want more solutions than 2/3 and 10/3? Add 8 to it. So add 18. What's 8 in thirds? 24 thirds. Yeah. What's more important? Getting these two answers than worrying about them. But it's good to do. All right, so at least get me 2 answers, but understand how you can get more answers. I'll do the last 2, see if you can do it. 5 over 6s, 5 pi over 6, 7 pi over 6. Plus coterminal angles. Get rid of the 2 by multiplying everything by 2. Over 3, so this is going to be 5 pi over 3, 7 pi over 3, plus multiples of 4 pi. Make sure you can get those. Vertical, root 3 over 2, pi over 3. Sign is negative. The pi over 3 in the third and the fourth quadrant. When is the pi negative in the third and the fourth quadrant? Let's go over to 3 pi over 3, 4 pi over 3, 5 pi over 3, or 6 pi over 3 minus pi over 3, 5 pi over 3. So we want 4 pi over 3, 5 pi over 3. All coterminal angles. Solving for x by dividing by 3 pi. Dividing is the same as multiplying by 1 over 3 pi. I don't like to divide fractions by things. I'd rather multiply by reciprocals. So instead of dividing by 3 pi, I'm going to multiply by 1 over 3 pi. This is good review of, just solving. The pi's will cancel, the 3's will multiply, the pi's will cancel, the 3's will multiply, the pi's will cancel, we'll just have 2/3. The 4/9, the 5/9, the more important part, the plus 2/3 n, also good. If you want more solutions, add 2/3 to any of those answers, okay? All right, I hope we're good. It's a good start, good review. Depending on your pre-calculus class last year, the next 3 lessons are review as well. But again, I'm trying to, start over with everything. We'll jump into unit 1 next class, which will be on limits. And then we got continuity. Then we got asymptotes, which kind of sets the stage for unit 2, which is when calculus really starts, where we learn about what a derivative is. Okay. Hope things are going well so far. Stop by the math office if you have questions. Make sure you're watching these videos if you have questions, and I'll see you out there. Peace.